and I'm the member of International Union of Industrial Society also, and German Technology Society. So there we have discussed. I've discussed my work that we have initiated here towards developing, the same lines of the drug for the TB, especially the non-reactive. Yeah.
Good morning, sir. I'm Dr. Manoranjan Nayak, working here as associate professor and Ramalingam fellow. So earlier I was at IIT Kharagpur as research assistant professor. Before that I was at Korea Advanced Institute of Science and Technology. So here we are working on microalgal biorefinery. So we have developed microalgal biorefinery lab in both in-house and outdoor cultivation system also. We have pilot scale cultivation in outside, so that we can study the feasibility of our laboratory cultivation in outdoor system, so that we can collaborate with industrial industry. So what we are doing, we are using different waste like wastewater, domestic wastewater, municipal wastewater, and industrial wastewater, and waste gas also, like flue gas, which emit from the industry, that is rich in carbon dioxide. We are utilizing those flue gases from different wastewater for the production of biomass, microalgae biomass, microalgae yeast co-culture biomass, microalgae bacteria co-culture biomass. So we are targeting to improve the biomass, and from the biomass we are targeting to different fuels like biodiesel, bioethanol, biogas. So different fuel we are targeting, and bio oil also. And in addition, we are targeting different value-added products like Putra and different luteins. So our work mainly focus to waste. Different, we are using waste and developing well. Zero waste biorefinery target we are doing. Thank you.
Very good.
Very important area, biofuel. There is an international mission on biofuel. So take his guidance.
Yes.
I met him yesterday.
Yeah,
From best to wealth guy.
Yes, RKC.
Good morning, sir. I am Dr. Ravikant Singh. I am professor in MT Institute of Biotechnology. I did my master's in biotechnology from IIT Lucknow, and dissertation work completed at ITRC Lucknow. And during my dissertation, I worked on genetic toxicology, mainly focusing on assessment of DNA level, how the DNA level damage can be occurred due to the various pollutants. And comet assay techniques I worked on during my master's, and after PhD. In PhD, I developed activated carbon from parthenium, because parthenium is hazardous in nature. When I was in IIT Roorkee, then the parthenium created a lot of problems, and from that source, I was the first scientist and researcher who gave a concept to we can develop activated carbon also. And during my PhD, I developed biological based activated carbon and designed a fluidized bed bioreactor for large scale industrial wastewater treatment process. And I started my career in different various engineering colleges affiliated with UP Technical University, which is the state technical university. I worked in different capacities as a dean academics, director research, head of department in various engineering colleges affiliated with UP Technical University. I joined this MIT University family in 2018 as a director, MIT Institute of Biotechnology, MIT University Raipur campus. And I established biotechnology department at Raipur campus and got certain funded projects also in various engineering colleges as well as the Raipur. We worked with the UNICEF project, got a fund from UNICEF also, from CG Biodiversity Board, Chhattisgarh Biodiversity Board, and Government of India. And after establishing and doing my job at Raipur campus, I joined MIT Noida campus because this is a prestigious campus, MIT Noida, and I am working and in the area of waste to wealth, how we can convert waste into wealth in different aspects, because during my masters and PhD, I work in the environmental area also. Right now we are developing, we have developed plant protector paint from fly ash, biochar from biomass and domestic waste, and with the help of solar pyrolysis, I designed a solar pyrolysis unit by which we can develop to biomass into the biochar also. This is the major area of mine. Yeah.
think we can start, okay, and then later we can discuss it.
Good morning, sir. I'm Dr. Abhishek Sengupta, and I'm from Biotech Department in the Center for Bioinformatics. I'm basically a bioinformatician, and I did my master's from Nottingham in bioinformatics, and did my my PhD in systems biology, in metabolic networks, and then I joined MIT in 2009. It's been a long time, and I am running a lab where.
Yeah, please go ahead.
We're very sorry, sir.
No problem. Please come.
So we'll just.
Yes, one of Pooja can.
I can sit here. Okay.
Can we get some more chairs?
Support chair.
Excuse me, ma'am. Happy for us.
Yes, so I have a lab in systems biology and data analytics where we work on reproductive health and reproductive medicine. So recently, I got a project in like a predictive AI in predicting IVF, the outcome of IVF. So that is going on, and recently I have a copyright which was granted, has been tech transferred by a company. So that is basically a male fertility predictor based on Y chromosome microdeletion, which has been tech transferred. So we are working more on the reproductive health area using bioinformatics and systems biology and AI. That is our niche area, but other work also we do.
Fantastic.
Thank you. Ma'am.
Yeah, please.
Hello, I'm Dr. Shapnika Das from AIB. I'm at the Center for Marine Science and Technology. Yeah, so
Yeah, please.
currently I'm working on mostly my niche area is like ecotoxicology, but we are having current mutual interest with seaweeds also, and we are trying a lot of things. So we are trying to cultivate seaweeds and make some bioreactors and take out some bioactive compounds. So yeah.
Congratulations. Yesterday I received message from Pooja
Thank you, sir.
and for this. Why don't you mention about that?
So actually, I've been invited as a invited professor and researcher/researcher. I'm an assistant professor for now. So in University of Lille, I'm in the Laboratory of Oceanology and Geosciences, which is a CNRS lab in France. And out of the Faculty of Science and Technology division, I was ranked third. So
Great, let's give a big clap to.
Shagnika. Yeah.
Very good.
Thank you,
So,
sir. Thank you.
now we will hear more about you
Sure.
and also your research accomplishments with CRNS. And this is very important in France.
Yeah. It is a central research facility, right? Right, exactly like the ST or CSR. Yeah.
Congratulations and wish you many more blessings.
Thank you, sir.
Wish you many more achievements throughout this.
Thank you so much, sir. Thank you.
And I think
Why don't you replace me here and then you sit here and speak your work?
I think we start and then.
Good morning to all of you. And Dr. Selvamurthy, who is DG STIF, Chancellor, MIT University Raipur, and today's guest, Dr. Yogendra Sharma, Dr. Neeraj Sharma, Dr. Gopal Bhushan, Dr. Pooja, senior faculty members, researchers, and friends. On behalf of the founder president, on my behalf and on behalf of all of us, I say the whole MIT family, we welcome you, sir,
Thank you very much.
to the MIT, and we are obliged to you for sparing time. And today is your second day with us on the MIT campus, and that also shows that you trust us, you trust the MIT, And you are in one of the 15 campuses in this country, around 15 campuses, and one of the 30 campuses at the global level. That gives you the dimension of the MIT universe. And MIT is, not the private setup. It's the fact now. And yesterday, when you were interacting with the founder president, then by now you must be, pakka ho gaya hoga. This is the foreign university in India. That what he mentioned. That after visiting, I find that MIT is a foreign university in India, and it is largest, most vibrant, and ever accelerating pace. It is enhancing. And I think details about university will be shared by Dr. W. Silvamurthy. And I'll say that I'm about 14 years old in this setup. And I find it's a unique place to work, where I find that, all the facets of life or for the career or for the profession are being inculcated into the students, and which through various enabling schemes, enabling institutes or enabling teams, and everything is driven by the honorable founder president whom you were interacting, Dr. Ashok. Now coming to Dr. Yogendra Sharma, I think I was thinking how to start introducing Dr. Yogendra Sharma. I'll say that he's not only the expert, he's an authority on protein, and he studies all the aspects of the protein, right from protein-protein interaction to protein structure understanding, its expression, or site-directed mutagenesis, and ultimately and particularly on the calcium binding proteins. And main impact of his research for last 3-4 decades had been in discovering and establishing the novel family of calcium binding proteins, what we say, beta gamma crystalline superfamily, and which is the second largest calcium binding family after EF and family. When I say EF and family, the name comes from because it is in the shape of forefinger and the thumb. I think he's explaining you more. And another work which has made impact is the deciphering the role of secret agogen, which is a protein, cytoplasmic protein, which binds to the insulin and protects it from the stresses, stabilizes it, and ultimately these two things lead to its better working or efficiency. Thereby, it's for as an anti-diabetic. And this work of his drew a lot of media attention. His work appeared in Hindu somewhere in 2019 November, and also in the Vigyan Prasar. Lot of media attention was drawn. And if we see by long tenure of about 3 decades, he has made impact in the scientific fraternity, and which is testified by his publications, and he enjoys the H index of 31, I-10 index of 62, about 129 publications, and he has guided 15 PhD students and has about 2,700, more than 2,700 citations. And he is also a recipient of CSIR Young Scientist Award, member of all 3 academies, and also awardee of J.C. Bose Fellowship. And how he could reach to that level. Dr. Yogendra Sharma belongs to the Bulandshahr, a very next district. That's why I think he loves so much this area. And he obtained his bachelor's and master's in physical chemistry from Meerut University. Then he shifted to Shah Institute in Kolkata, then where he got his doctorate, and immediately after getting doctorate degree, he joined CSIR in CCMB. Then he grew up the career, and in 2019 he superannuated as the leader as scientist G, and he was heading a big team there. And after that, now at present, he is Dean and Professor of Biological Sciences at a newly constituted, established ISER Barhampur. And in between, he had a tenure of 2 years as a visiting professor in Washington University, St. Louis. Now, with this, if you really see, he is a unique amalgamation of chemistry, physics, and biology. And if I use this is a deadly combination. And his accomplishments and the impact which has made are unparalleled and praiseworthy. And with all this, I think we are so lucky to have you here. And I had been interacting with you, and it's love talking to you. He's a very simple man, very simple man. And whenever you interact with him, you would like to talk to him more and more. Very knowledgeable. Thank you very much, sir, for coming here. Now, you want to say?
Okay, whenever I am allowed.
So friends, good morning and thank you Dr. A.K. Singh for introducing such a distinguished guest in a very lucid and befitting manner. And my compliments to you, to Dr. Vivek Sharma and the whole team of SLT Warriors, ABSTIA, for organizing this meeting as well as for the visit. Particularly Shefali, I must compliment her that you have brought him and then also coordinating under the directions of Honorable Founder President. So compliments to all of you and to all my faculties who have come in spite of all their other busy schedule. They have made adjustments to listen to you and to harness the benefit. Above all, our Honorable Founder President has only joined and is listening to the program. In spite of his other schedules, you can imagine a person who runs a universe, a bit universe, but still finds time and he is listening to all of us. And maybe sometime later he will also interact with you in the evening, or maybe even later tomorrow or day after. So, Honorable Founder President, thank you for connecting with such a great luminary and also a person who has accomplished in research, innovation, academics, and Yogendra Sharma. This Yogendra Sharma is from a very important lab, CCOB, Central Council for Central for Cellular and Molecular Biology. A lab which is a very important lab in SCSIR, with whom we have a long association, we have collaborations. So now his coming here will further expand, deepen our relationship as well as our collaboration with you, as well as with your earlier institutions, through you, CCMB, as well as ISER, which you are now the Dean Faculty Affairs, Deputy Director in ISER Barampur, and also Professor and Chair of Department of Biological Sciences. So that's the current position you hold. So you are here to listen to a very important person, but before that, Founder President suggested he should get a comprehensive picture about Amity Group in terms of our research, innovation. So even though you may be knowing, but then I thought it will be a reappraisal for you also, that I will give a little glimpse, take you around for the next 15 minutes, that what Amity Group and how the Founder President is giving a focus on research and innovation. So I do a few slides, just share some. But by now, you might have got some idea about the Amity University of Uttar Pradesh, Noida particularly. But we will now take you to other campuses, what they are doing, and where all we are. And he mentioned about 12 universities in India and 18 campuses abroad. So I'll show you some of them, how it looks like. So we welcome our Dr. Yogendra Sharma ji. Can you go? And you might have got some idea about our founder, but I thought I will elaborate a little bit. Because he is the founder and also the prime mover and currently the chairman of the whole endeavors which is happening for the Amity Universe. He takes decisions. He works 18 hours a day. A man who hails from a a modest family background, teachers, government servants from Meerut, and then studied in Meerut University, masters in chemistry, and then moved to Germany. Did his doctoral program there in chemical engineering, in polymer chemistry, and then he became a member of that team of R&D, and then he won that R&D, and then ultimately he owned many companies there, and he employed more than 6,000 Germans and other internationals in Germany. So this is the story of this man who created the universe. He has brought the best of the West, which he has learned over 28 years of his stay there, and then the best of the West, best of the West, and then best of the East, with whom he has grown, which is there in his DNA. So the Amity today is growing as a hub of repository of knowledge, hub of innovation, so which is being driven by all these distinguished faculties, HOIs, and thank you, Founder President. And we are also a strong believer of God. He's a spiritual person who connects directly with God. And then he says, quote, when God pushes somebody, inspires somebody, leads somebody, no power in the world who can stop such a person. He himself is an embodiment of what he says. Now, the organization is also led by young dynamic leaders. We have Dr. Atul Chauhan, a product of London School of Economics, both in engineering and management. And then he is the president of our foundation, the RPF, Return Ballian Education Foundation, which gives cover to all Amity institutions, including the school. And schools are being looked after by Dr. Mrs. Amita Chauhan. There are 28 schools which are being looked after by her. Among them are in foreign countries as well, like Amsterdam, Abu Dhabi, Sharjah, and even in South Africa. So we have schools not only in India but across the globe. And Dr. Asim Chauhan is the additional president of the foundation and also the chancellor of Amity University, Haryana, Rajasthan, and also Amity University, Chhattisgarh, chairman. So like that, Amity University, Maharashtra, Mumbai. So he looks after a few campuses and also he campuses abroad, like US campus and so on. So he is a product of Wharton Business School. And Mr. Amol Chauhan, who is the executive director in founder president of, is the product of Harvard School, Harvard. So like this, we have very distinguished people who govern this whole group, which many people may not know that they are all well aware of the educational system across the globe, research, innovation, entrepreneurship, startups, venture, everything they are aware. These are the campuses which we have in India. Some of them I have put. Each one has a landscape and also its architecture and also verticals inside in terms of its competence. So we have some of them are shown here about Noida, you are here in Delhi NCR, Gurgaon, in Maneshwar. We have in Haryana, then Bangalore, the latest one is in the Bangalore, which is operational now. We have started the admissions. We have already enrolled more than 500 students there. Then Amity University, Maharashtra, Mumbai, Lucknow, we have a campus, which is a campus from AEUP there, Amity Lucknow. Jaipur, Amity University, Rajasthan, Amity University, Madhya Pradesh, Gwalior, Amity University, Chhattisgarh, Raipur, which I am honored to be the chancellor there. Then Amity University, West Bengal, Calcutta, Amity University, Ranchi, Patna, Mohali, these are the campuses. Now the latest one, which is in the offing, is in Telangana, which will be next year, 2024. That we will become operational. That will be perhaps the 13th one. Then we will also have one in Tamil Nadu, which Founder has already started looking at Coimbatore as a potential site. We are still in a thought process now. So that will be the 14th. So this is how Amity is growing exponentially in India. Now coming to global campuses, we are not only pan-India, but we also have global presence in many places like Singapore, Mauritius, USA, 2 campuses, New York and San Francisco, Amity Dubai, Amity London, Amity Tashkent, Amity Nairobi. So like this we have Amity San Francisco, Then we have also in a few more countries, and so this is how we are. We have in 18 countries. Our presence is there. But the founder president vision is we should be there in every state of India, and also 50 countries. So this is his dream, and which should happen in 1 decade, next 1 decade. So the whole missionary is gearing up to meet those targets which founder president has said. I would like to particularly bring a focus on Amity University, the Long Island, which is 175 acres, a big asset which has been bought out. It was a St. John's University there, which was functioning, but then we were able to get this property, and then we are developing two things there. One is school, which is Amity Harrow School, which is already functional now. We are renovating the building for the school to be operational next year. And then we have also developed Amity University Long Island as a global research hub, where the whole Amity group, research and innovation, will be connected to the institutions in the US. So this has a very big role to play in terms of global research hub, in which we have created some verticals: sustainable development, research in niche areas, emerging technologies like quantum technologies, artificial intelligence, Indian systems of medicine like yoga and Ayurveda, and also we would like to have cancer biology as yet another focus area. So like this, we have thought of a few verticals which we are in the process of growing. Then we also have Harrow schools. Harrow is a very important partner for us, and Amity Harrow in Bangalore. We have not only in US, but we have Amity Harrow partnership. We have started the school already, and I met some of the students there. There are more than 120 students who are there in the first batch. So we have a school and the university together. It's a very good model that Amity Harrow School on one side, and on the other side, we have this is the school which is operational in Bangalore. So even faculties may not know. So please, whenever you visit Bangalore, visit our new campus over there. We run more than 300 programs, UG, PG, and doctoral, postdoctoral programs in these areas, which covers almost everything you name. But some of the niche areas, I would like to say aerospace technologies, where we have given a space and science and technology, space science and technology also. Then nuclear science and technology, post-harvest in agriculture, neuroscience, then nuclear science and technology, and virology and immunology, and a strong biotechnology, some of them are here. So you name any discipline, Amity gives. So it is a multidisciplinary group of universities. So each university will have various disciplines. So that could be seamless multidisciplinary approach to research and innovation. So even a management person, how do you manage a project? Project management expertise will come. How do you do a business development out of the outcome of a project? You have the MBAs and the business schools are available. Marketing. So all this is available. So that is the unique strength. And we allow that seamless connectivity. Not only we are biotechnologists, will connect with engineering assets so that whatever scientific lead gets converted into a device or a product or a system of systems. So we have engineering. So like this, it's the multidisciplinary. That's a unique strength. Not only having multidisciplinary, but also actually connecting with them with seamless connectivity. We reached the university ranking among the 1100 universities in India. We reached actually 22. And then now we are at the 35, at the pharmacy 21, management 28. So we are in top 50 in almost everything. But then we want to be, we are not satisfied with this. We want to move to top 20, top 10 in most of these areas, for which all our faculties and we are all working together. Then we also have very important accreditation, like NAC, we have A+, but we want to become NAC A++. This re-accreditation is on now. Soon we will be submitting the SSR. And we also have global recognition, QS ranking. We are among the top private university. We are number one in private university. When we look at academic institutions, Indian Institute of Science, technical institution, IIT, Mumbai, and private central university, we have Delhi University on JNU. Then we have Amity University on the private universities. So like this, we stand in the global level at QS ranking that we are the number one private university. We have ASC accreditation, we have THE accreditation, and
The Indian Intellectual Property Office of the Government of India has conferred the National Intellectual Property Award 2020 on Amity University for Top Indian Academic Institution for Patents and Commercialization, a reflection of Amity's commitment to research and innovation.
you'll be happy to know that Amity has filed more than 2060 patents and almost 300 of them are granted. And many of them are now getting translated into product, technology, processes, leading to commercialization. We have done so far about 35 technology transfers in the recent years, and then now that is being given a push. That is why the Amity Center for Translational Research has been established to give a focus, thrust on the translation from scientific needs to a product. So the message is very clear to all our faculties who are here, who are attending online, that now founders would like to contribute through you in Amity to Atmanirbhar Bharat. That is translational research as the focus. Our culmination of research should be either in a deliverable or solving a problem of the society, or it should be a path-breaking research outcome, which will have application subsequently. So it's very clear message from the higher management to all of us. Just to give a glance of what is research achievements, we have today 200,000 students, so they are the assets. So we are involving them in research and innovation. Not that they are only doing academics and getting the degree. Even at the BTech, BSc or MTech, MSc level or doctoral level, that the focus is on research, curriculum design, pedagogy. Everything is aimed towards making them, promoting creativity, innovation, problem solving ability to these people. So currently we have 200,000 students, 700,000 alumni across the globe. So you can imagine in the next 10 years, what will be the force, Amity force across the globe. And we have established chapters of alumni in USA, Canada, Germany. So like this, we are establishing chapters, alumni chapters in those places where so many people are abroad. Then our H index today, with more than 35,000 publications in journals of repute like Nature, Lancet, Cell, Royal Society of Chemistry journals, Advanced Materials, Material Horizon. We have top publications, and H index today is 134, but it's just moving faster. We want to reach in another month 140 and then to 200. So the goal is very clear, because every faculty is given a target in terms of projects, patents, publications, consultancy, extension. They are clear what they want to do. So targets are given to institutions, and which percolates down to the grassroots level, to the society, to the faculties, and they in turn work. They keep a dashboard and try to achieve this. So this is the type of culture which we have. Everything has to be time bound. Similarly, Amity ecosystem has all that what we require. Seamless connectivity with stakeholders who are industry, laboratory, other laboratories, other organizations, society. Then IPR protection cell, innovation and technology transfer. We have a cell, Dr. Meenakshi will, I hope she will also interact with you. Amity Center for Entrepreneurship Development. So such all that processes, policies, practices which are required exist in this ecosystem. Then we brought senior people, like today you see here Dr. A.K. Singh, Dr. Neeraj Sharma, Dr. Gopal Bhushan, and Dr. Narayan Rishi, such senior people, and we are connecting with you. So senior people, they have rich experience, expertise, wisdom, and then they mentor young faculty. So you see here. So we guide them, enable them, motivate them, inspire them. That is the secret of the success. Dr. Chauhan always says that we bring the blend of the senior people with all those which I mentioned, and the young, energetic, enthusiastic, the young faculties, Ramalinga Swami fellows, Ramanujan fellows. So this is the asset, the organizational asset. So we have such people. I showed the older people. I have picked some of the younger people. Maybe Manoj is here, and Pallavi and others are in the laboratory, Saitya Datta and so on. Then we also connected with honorary professors and adjunct professors outside Amity Group. This is a force multiplier. So we give honorary professorship, honorary doctorate to eminent scientists and faculties. They act, our people link with them and they harness whether it's a bilateral scheme or a multilateral scheme or any guidance or for a conference, they're all invited. So we connect with them actively. So this is another asset outside Amity whom we hold them also as our human resource. Because, and even Nobel laureate, we have brought 8 of them at our cost recently, and then we have established centers like Richard Roberts. We have developed a GMO centers. He got Nobel Prize for gene splicing, DNA splicing. So we have established a GMO center. So like this, we brought Takaki Kajita from Japan, a particle physics man. And so we have established a fundamental physics center here. So like this, we established center and connect with them. And Dr. Nidhi Chauhan was here in the AAT, worked with the Nobel laureate for 4 months. She went to that lab in Australia and worked. So like this, we connect with even Nobel laureates. And we created infrastructure. Many of the labs, some of them you will be going there. This is Dr. B.C. Das lab, molecular medicine and stem cell research. So Amity has invested, besides the other government funding, Amity has made its own investment to create such wonderful facility, even central instrumentation facility in Haryana. When you visit our Manesar campus, 8 crores were invested only to develop a central instrumentation research facility there with modern sophisticated instruments. Like we have fax machine, you might have seen in molecular medicine and stem cell research. And for all cell studies, CD4, CD8, NK cell, PHA, all those. And then R&D infrastructure like this cold storage for post-harvest, HPLCs, atomic absorption, scanning electron microscope. So like this we have, and these are some of the infrastructure you'll be visiting. Then we were driving through missions, various missions. Mission Connect, now we are connecting with you. And what we expect is mission synergy. Synergy for you, synergy for us, synergy for your institution. So mission synergy, but it should lead to an outcome. So ultimately, whatever we do, it should lead to a fruitful outcome for both the partners, collaborators, and to Amity. So we have kept these missions founder president has established to drive the whole system. And so that is how we achieve things faster. I'll conclude in 2-3 minutes because I won't go into the scientific aspects. We will see them on the laboratories. I will only give the ecosystem so that you will be able to grasp how the system functions here. We have a technology enabling center. We have a scientific lead, and that is a TRL level 2 or 3. How do you make it mature the TRL level to 6 or 7? So we have a technology enabling center funded by DST, thanks to Dr. Neeraj Sharma, who was the brainchild of this whole program of TEC, Technology Enabling Center, who is here now. And so this was the first center established in the country out of 9, first 9 centers. Amity was the first TEC center, and which has done very well. Then we have an incubator supported by DST, huge, maybe the best in the country today. You will see it today. Founder president was very keen that you should see 2 things today in addition to other labs. One is library, huge library we have created. Another one is the incubator, which has incubated more than 750 companies in physical as well as virtual. And we have a capacity in 3 floors. We can have simultaneously 300 people can incubate in person physically. We have churned out about 90 startups which have come out very well, which include some student startups as well. And we have nurtured them both from business point of view as well as from the financial point of view as well as technical point of view. Then the target we have kept, founder president has given, we must have equities, 10 to 15% or 15 to 20% equity in 1,000 companies. And he has allowed faculties also to be simultaneously director of a company. Suppose if you have a technology, you want to start up a company, we encourage. Founder president gives facilitation to that as well. Like we have only a few of them which have come out, but more, he has expected more, 25 faculties this year, and which we are making it happen. So this is how the whole system functions. Now we are very eager to listen to you. These are incubating, and these we have a very strong industry connect, which is important for the technology transfer and co-development of technologies. And we have brought industry to our campus. This is beginning has been made, like Tata Technologies. I wish you see maybe this visit or next visit. Tatas have taken 30,000 square feet here. They have been given. They have put aerospace and automobile and also robotic manufacturing facility here. And 8 of their engineers are sitting here in our campus to groom our students. So we are not only connecting with industry, but we have brought industry to our campus. Similarly, KPMG, RIGS, we run programs, CAA Logistics School, we have RIGS, we have built-in environment, and we have formal connecting institutional membership with FICCI, CIA, ASSOCHAM, all this area, and the NRDC Facilitation Center. And we have MOUs with more than 102 national and 192 international MOUs, particularly with government organizations like Indian Council of Agricultural Research, Indian Council of Medical Research, Council of Scientific and Industrial Research, and DRDO labs like sensitive labs like TBR and the SFPM. Yesterday we signed an MOU with SFPM. So like that we have MOUs with DRDO laboratories, hospitals, 12 hospitals we have formal MOUs, active MOUs, IITs. We have a consortium with IITs. So this is a golden place where one would like to express their potential. All these are available, opportunities available. IIT Guwahati, IIT Hyderabad, and all this, we have IIT consortium led by Basant Singh Shikarwar, and we have, and Amity was chosen as the hub to run a Stuti program, where 22 spokes were IITs, JNUs, BHU, and like this we had the spokes. So we served as hub for capacity building, for training people in this. Now that will be my three more slides. These are the expertise available. Computational biology, cancer biology, translational research, molecular medicine and stem cell research, genome engineering, neuroscience, which is also one of your domain, like the ion channels, Cal modeling, all this your work, public health, strong public health, clinical chemistry, you visited yesterday, drug design and discovery, and also atmospheric science and Indian systems of medicine. We have a separate institute here. Yoga, Ayurveda, and Unani. We run projects in these areas. Other areas include AI. We have put a strong artificial intelligence center of excellence with 10 petaflop capacity today, which is going to be 60 petaflop. We are going to augment it to that capacity. And then we have nanotechnology, cyber security, food and agriculture, strong vertical in agricultural biotechnology, bioenergy, post-harvest. So these are the domains in which Amity works today. Now I'll stop here, and we have many funding projects which you will see some of them. Like we have a $1 million investment from US Department of Defense here on nuclear security capacity building, which is an Amity Institute of Nuclear Science and Technology. It's more than 1 million. So, which is to build capacity. Similarly, DRDO, one of the project is AI-based identification of personnel. So, like this, we do international projects, national projects of great importance. So, thank you so much. All this, the credit goes to our faculties. They are bringing whatever I showed is because of their efforts, endeavors. So, thank you so much. You people are doing a great job. And we want to, founder president and our expectations from you have gone up. Why we wanted you to listen to you, because some of you are new. And also you must know, feel pride that you people have achieved so much. So let's clap for each other. Clap, big clap for you all. And the founder president, you are giving inspiration and motivation to all of us. Blessings for all of us. Founder president, we can hear you. Thank you, Founder President. I want to hear your words of blessings and words of wisdom. Over to you, Founder President.
Dr. Silvamurthy, I was attending another online meeting, but my people came running. Dr. Silvamurthy is speaking. So I excused me from them. I told Dr. Silvamurthy is speaking. I'll come back in 15-20 minutes. What you speak, what should I say? Dictionary of MBT? Lexicon is the word, a German word or English word, lexicon of MBT. So I go on giving you the titles, supersonic, hypersonic, what else, but what you know, I think to deliver in about the time was given to you. Shefali, now you know that you were giving 15 minutes. I told give Dr. Salamurthy at least 45 minutes per hour. So I think what you deliberated very interesting. Dr. Yogen Sharma ji, I welcome you, and we will also I will also listen your deliberations because we are very proud. Yesterday, 2 hours mid in the night, I read all his biodata, the papers he has published, with whom he has published, his 31 H index, 90, 31, 63 I index, and 6,269 papers, no citations. Am I right? 6,000, no, 2,669, something like that, citations. Because, my dear, all scientists, technocrats, if you want to know about the scientist or researcher or innovator, just see his H index, I, H factor, I index, and the citations. And so we are proud, Sharmaji, that you have such brilliant, such a technical, innovative record. Dr. Smriti, I welcome all my scientists, those who have gathered here. Shefali, I appreciate you. You have very laboriously and with great efforts made this all so happen. And Dr. Modi, we should have a party sometime. Dr. Shefali has just got his PhD. So I'll give you a party when I come next time. And we'll all congratulate her. Right. Then Dr. Modi, just when I see my people and you, I have some idea always to take advice from you. Few days back, I heard our Honorable President Modi ji that he told I will make 2,000 farmers Lakpati. You know, my dear scientist, Lakpati is 100,000 rupees. I will make my 2,000 farmers Lakpati. I was thinking that I should give a figure announcing, for example, I'll make my 100 scientist millionaire, first in rupees and then in dollar. It's possible. Recently, Pooja wrote, we Pooja, that there is a lot of scope for getting industry projects. Then our startups, it's a gold mine. If a person has a own startup, you can make as much money as you like because Shivani will be a sample for that, an ideal example for that. So I would say I will have A.K. Singh ji, Neeraj Sharma ji, and all my warriors make a thought, brainstorming what founder president declared today to consider uh, millionaire scientist, innovator, faculty members. Trustworthy, this is possible.
Yes.
This is possible.
It is
Because this is possible. 10 lakh rupees, I think, makes a million. And because my scientists have all capability, all innovative power, but as you very rightly told, my zanoon, I would say my craze for outcome. I was talking to Dr. Namurthy, my dear faculty members. I want 100% outcome. No compromise for that. If anybody does not achieve it, I will make a hut for them in some mountain, pay them full salary. And I say, why you worry? Why you work? You go with your family, enjoy there, I'll pay your salary. 100% outcome. And Dr. Namurthy rightly also told 20% non-tangible, which is with every seminar, with every meeting, with every visit, but 80% tangible outcome. So, my dear scientists, although are sitting here, you are deliverer, you are achiever, you are innovators. That is why I say, my dear scientist, my pride. I will listen now also later, Professor Sharmaji. Welcome to all of you. And I will, in the meantime, maybe again going to the old meeting going on and will join again. Thank you very much.
Thank you, Father President, for your blessings to all of us and also bringing such a wonderful person because you were responsible for Dr. Yogendra Sharma to join us today at this. and thank you so much. And in spite of your busy schedule, you could peel off from that meeting and then join us and give the words of wisdom and also message to all of us about how this outcome, which the mission outcome is being driven by you and which we commit, we assure on behalf of everyone. We will bring that 100% outcome in whatever endeavor we do, 80% tangible and 20% intangible. Thank you so much.
Correct. Great. Shefali Arjinder, now the next thing to bring Himanshu to your as Ramanujan Swami Fellow. Well, Himanshu got also he's getting Ramlinger, but he got also Ramanujan Fellow. So I think what a brilliant person he must be. So I think Arjinder is attending the Ramanujan Swami and Shefali Sarvsaya. So you wanted to say something, sir?
Many things actually. First thing first, मेरा मुंह बंद हो गया because of hearing him
Right.
and looking at that MET universe. Because
Right.
first thing I need to do, I need to write a book how to create a MET universe. How was it created? It is nothing to do your biography. It is about the entire phenomena. Okay? So I need to write that something just for my sake. Second thing, in the morning I was talking to Sefali that why were you so late in connecting with me? Because when I was the director and heading ISER, she should have connected me and then I could have actually done couple of directions to her and some ideas and some basically because I used to get all the applications of those fellows, Ramlinga Swami, Ramanujam and etc. So there is a lots of potential in MET. MET is doing wonderful. So yesterday night I was strolling in the campus and I was sharing with Dr. Singh and Dr. Sharma. These were two gentlemen I met first time and मुझे लगा कि मैं इनसे पहली बार नहीं मिल रहा हूँ. I don't know. These two people came smiling as if मेरे को बचपन से जानते हैं. And then Sefali is so dynamic. पता नहीं कितने किलोमीटर yesterday she walked in the campaign and I was worried about the poor girl. मैं भाई तुम पैदल मत चलो because I can walk. I am a long distance runner.
Right.
And then I was just asking her कि भाई तुम अपने हिसाब से बैठो. I can walk. For me it is nothing.
Marathon run करते.
Yeah, they are all very healthy and they have to be healthy. They are deliverers. They have to work long years. Sir, with the advice and guidance direction from people like you, my mission is to make MT University best in the country. I have no desire to compromise on that and among the best globally. And you see, when you see my people, I think Dr. Chauhan is not only dreaming, he will realize it. My people are so sincere in devotion. I don't think there is any other university in the country. If somebody will bring me either university, their people are as good as my scientists, I'll give them an award. But still now, nobody has brought it. And your presence has further motivated me, inspired me. Yesterday, 2 hours, I read your full biodata again. And I read CCMB, where Dr. Murthy has been three times. Dr. Murthy, CCMB is, I'm astonished. I had not much knowledge. My daughter-in-law, Soumya, my chancellor's daughter, is studying in Rice University, USA, this genetic engineering, biological area. And I immediately photographed the WhatsApp, sent her the CCMB. I told Soumya, you read it all. This CCMB is something, it is very difficult to grasp for me by one reading, but we'll ask Yogen Sharma ji because he has been 3 decades there. And Dr. Sharma ji, one thing more, you did your MSc from Meerut University in 1980, correct?
Yes, 1980, yes.
I did from the same university, from the same classroom, from the same lab in 1963.
हाँ थोड़ा टाइम गैप हो गया अदरवाइज वी कुड हैव बीन क्लासमेट एंड आई कुड हैव बीन
Right. And you did it physical, I did it inorganic.
yes.
Mehta was the head and Bhargav was inorganic and Joshi was physical. I don't know if Dr. Joshi was that time there. So these were our professors. So I was very glad. So Saudi, I have a very much similarity. He belongs to Bulandshahr.
Yes.
As I told, I did my ninth and 10th class from Bulandshahr. And I had long years in Meerut. And I think he has been very much connected to Meerut. So now the only thing is to get him connected to MIT.
Which is already being
Already connected.
Dheeraj ji,
He already did that job actually. Look.
And he has started loving MIT now.
Yes, he didn't even ask me. He directly connected me with. I was only late.
जिसको हमने लेना होता है मुझसे पूछते ही नहीं है उसको पकड़ के ले आते हैं शिलामूर्ति को मैं लाया हूँ मुझसे लोवाइडी फैकल्टी मेंबर पूछते हैं कि शिलामूर्ति कैसे आए आप लाए मैंने कहा नहीं वो आए मैंने कहा नहीं वो कहते फिर क्या मैंने कहा भगवान ने भिजवाया दिस इज करेक्ट जो मेरे पास साइंटिस्ट बैठे हुए दे हैड मेनी अपॉर्चुनिटीज मेनी अदर यूनिवर्सिटीज बट भगवान ने कहा चौहान के पास जाओ दैट इज द बेस्ट फ्यूचर तो शिलामूर्ति एम आई राइट आपको भगवान ने भिजवाया
Absolutely. And also, last 10 years, I have become younger. People say that you look much younger and active than what you were in Diageo. So that is why this place keeps you challenging and active physically, mentally, spiritually. So
Right.
it's a place where if you want to achieve something, realize something, you can achieve it faster. And thank you, Founder President, for this blessing for all of us.
थैंक यू
Thank you for spending your time, and I hope to see you sometime in person.
नहीं मैं when you are in Dwarka I'll ring you I'll have a detailed talk with you when you are with your nephew I'll personally call ask you convenience I will have a big chat with you great
Okay. Thank you very much. Thanks.
So with this, may we now request you, Dr. Ibulur Sharma ji, to give your presentation if you have any PowerPoint
Yes.
presentation. And also give us the message that how we can now, with your expertise, how you like these people also to connect with your point with, and also collaborate with you all them. You can give some thoughts and share later. But now give us all your experience, wisdom in a big canvas which you have, and particularly in CCMB as well as in ICT.
so
Just forward, huh? Yes. इससे स्लाइड बदल देंगे या यस वहीं से बदल देता हूँ दैट विल बी हाँ ठीक है वहीं रहने दीजिए तो
इसको प्रेस
अब कुछ बोलने के लिए मेरे पास कुछ रह ही नहीं गया है I don't have to say very good morning once again and had a wonderful time. Thank you for spending time and listening me and my bakwas. Yesterday I had some time with Pooja and company. I should say because she was that she organized this. I thought I will have my presentation only limited to the biology group. And that is how I thought. I thought there may be a chance of interaction between me and them. But here I saw, see, our chancellor spending time, Professor Sharma, Singh, अपने जितने भी यहाँ के सीनियर लोग हैं, everybody sitting here, so I started thinking what to speak. इन लोगों के सामने क्या बोलना है मेरे को? So, the first thing is that whatever I speak here, नहीं कोई बात नहीं यहाँ से बदल देते हैं So first thing is I earnestly request you all to view this presentation with generosity and understanding. Do not take it anywhere ki boasting kind of thing. And I request sometime that may give a feeling, अरे भाई आप थोड़ा इधर आ सकते हो if you want to be here and then can be comfortable. No problem, just be here. We can make some little room.
There is a chair.
There is a chair here. I met him yesterday at the dinner. He got that award yesterday, Best Poster Award. We can clap him for him in that one. And very dynamic person.
What's your name?
He especially joined us to attend your talk, sir. He's from Applied Sciences Department.
Which department?
Applied sciences.
Oh,
So in material.
Yesterday you got the award.
Yes. In the material science conference.
Very nice.
Let's clap for him.
I don't have to repeat it that thanks to Sefali, thanks to Singh and Sarmaji and Selva Murthy and everyone. So let me speak little bit about something which I am going to share, and I don't want to talk about the pure science. I just thought to make an overview kind of a thing, and I was asked over and again, कौन थी वो निधि ने पूछा था या क्या भाई अपना तो इंट्रोडक्शन दे दो, and I thought आप थे, हाँ, so you know how science is taught in reality today? मैं चाय नहीं पीता हूँ, ये इनको दे दीजिए.
Herbal tea.
So, हाँ?
Herbal tea.
नहीं कोई बात नहीं, ये है ना गरम गरम पानी दे दिया था. No problem. But we want to read something to you that you know what we do not talk about in that anywhere else. How science is done, we never talk about this. So we do not get to know तुमने किया कैसे था. So I was reading a biography of Arnold Schwarzenegger, the bodybuilder. And I wanted to see वो करता क्या था, खाता क्या था. Nothing was written in that. Everything what was written in that one was कहाँ पैदा हुआ, क्या है ये, and how became a world champion and changed the concept of a bodybuilding, it was not there. I was not keen to know. So when I was a young guy, I was in the library. Those days, you know, there used to be the volume, and I picked up a journal of biological chemistry. ऐसे ही कुछ खोला तो एक पेपर निकला, something number 1, and then second paper, and then third paper, and then you know that who was the author? H.G. Khurana. देखिए दिमाग इतना मोटा था मेरा, I couldn't get to know that is हरगोविंद खुराना. H.G. Khurana मेरी समझ में नहीं आया. There are so many Khuranas, and there were 17 papers in one issue. 1, 2, 3, 4, 5. मैं देखा ये कौन पागल है भाई. JVC में he published 17 papers one after one, and I was curious how did he do that. So everything I got to know, and you also know what the research he did. But how did he do those 17 papers? That particular part is missing. So I share this quote to you all, that classical notion of the scientific lecture is to present only the selective data, and thus is an inaccurate representation of the way the research has been done or thought. I want to change this, and I want to say how did I do and what were my failures and how stupid I was. And this stupidity you will see, इतना बेवकूफ हम हो सकते हैं क्या. So I have to just talk little bit about that. The theme was always a health and disease, because without that you will not get a grant, you will not get a good publication. So practice was that go and attack a disease, human disease. So I was never interested in calcium binding protein. Who will like to work on RNA? छींक आ गई अगर उस कोने में तो RNA वहां डिग्रेड हो जाता है. Okay, it is such a stressful. You will not like to work on calcium binding protein because साला हाथ भी साफ, everywhere there is a calcium. But it just happened because we were working something, we were fascinated with a eye lens. It was such a beautiful marvel of nature. देखोगे ना तो कंचे की गोली खेलते हैं उससे भी खूबसूरत. And then that was the project was in the lab where I joined in CCMB. And idea was that it is related to the cataract. So I have to talk about little bit about that. You know that lens is made up of protein. So material scientists know, and then biologists and everyone. So only protein there are crystallines because it is a crystalline lens. That's all. भाई आप लोग मेरे को ना देख करके स्लाइड की तरफ देख लेंगे so that you know it will be clear and the direction is little bit something. Otherwise I can stand over there. So you don't have to bother about this. There are only 3 crystallines and they are named ABC or in a Greek letter that is a convention alpha, beta, gamma. Okay. So alpha crystalline later came to know that they are a heaps of protein, that is stress protein, and then others, beta and gamma crystallines, we didn't know what they are. So only thing is their structure is very similar. So they are called beta gamma together and nothing was known about this. And we thought let us work on this related why there is a cataract, why there is a mutation, and that was the idea. So how did we do and what we wrote? So you know there was a library and we used to look in the library every day and there will be a first table and there will be a journal received today. Then there is a second table, journal received yesterday. And on the first table there was a issue of a journal called biological, that faculty knows that it trends in biochemical sciences. And there was a review article on that there is a calcium binding protein EFN. Don't go into the worry that what EFN is. This is just a name of a motif where calcium binds. And there was a sequence analysis. We took the journal and we came to the lab and started looking at whether any of the crystalline have that kind of a sequence. And we just thought, ये लग रहा है. There are some aspartic acid, acidic amino acids are there, and then we thought, okay, it might be calcium binding. ये है जिसे बोलते हैं धूल में मतलब let us see something. And because I knew how to do this analysis, so we basically thought, let us do calcium binding. And we attempted it. किस्मत आपकी अच्छी थी या बुरी थी, I don't know. That one of those proteins we found binds calcium. Bhai Sahab, we wrote the paper and published in JBC.
Oh, very good.
That time, you know, it was a very good publication. And मैं सपनों की दुनिया में उड़ने लगा. मतलब, see, I thought now I will publish hundreds of paper on this protein because there was a calmodulin where we used to have 10,000 paper on that single protein. तो मैं कम से कम 10 तो छापूंगा. And that was something. But you know how we wrote. So I was talking about how we did. It was just the journal there on the table, but we never write. Okay, like this. So what we wrote? We wrote that calcium homeostasis is very important for lens transparency. Calcium remain in a bound form. मेरे बाप को भी नहीं पता था ये सब. But when we finished and we found that protein bind calcium, then we have to write something to justify. So there is a difference between how the research is done and how we write it. Okay, and that is where it came something. We have to write something. But मेरी जिंदगी वहां से basically बहुत excited. I was so excited because calcium excites everyone. That is the party of my lab. Okay. Now what happened? I don't have to talk. Calcium बहुत important है. Important क्या नहीं है? सेल्वा मूर्ति भी बहुत important है. एमिटी बहुत important है. तो कैल्शियम भी बहुत इंपॉर्टेंट है, बहुत सारे काम करता है. So let me, this is just a scientific jargon, but important for me was that calmodulin bind calcium. Like this we knew the family. So calmodulin belong to a family. Today, we have 1,000 members of that family. Then there is a C2 domain, which is there in the brain. There is cadherin. There are so many. So for me, was ye beta gamma crystalline belong to what? And I was too baffled. Ab main kya karu next time? So first question was that do as many things as I can do with that. फर्स्ट थिंग वाज ऑलवेज यू टू रिमेन ए डाउट सचमुच में बाइंड करती है क्या मतलब पैरानॉइड हो गए हम लोग एंड वी डिड ऑल द थिंग्स बाय व्हिच वी कुड सी okay beta carotin really binds calcium and it is a moderate to low affinity and basically अब तो मैं बहुत कुछ कर सकता हूँ बड़ी बड़ी मूछें रख ली ओके बहुत मोटा हो गया 120 kg का हाँ इतना खुश Now, what is that? That was the struggle that I started facing. Did everything. So I found a dye which probed calcium and we did the work, published again in JBC. What next? Nothing. I prayed for God. घर में आया मूर्तियां बदल दी खुदा का नाम याद किया but it remained enigmatic to me and I used to come and discuss with my colleague with मेरी सामने वाली लैबें कि मुझे क्या करना है what I even lifted very heavy weight doing a squat with 155 kg. Thought of quitting, तेरे बस का कुछ नहीं है, भूल जा. And lost lots of weight in this. Accepted that nothing will happen. But at some level, it is not that complexity that matters. It is the beautiful simplicity of the thing. Idea was, वो बेटा किस लिए ये मोटे साले तेरे को उतना समझ में नहीं आया that itself why are you basically talking about this that just talk it is the motive itself and then worked on it and then found अरे यार this is very right and yes it took more than 10 years just to say that beta crystalline itself binds calcium. Can you not say that I am such a stupid guy? हिम्मत नहीं थी कुछ बोलने की. Now, of course, there were lots of efforts in that to do that experiment, but that is where I couldn't express that how excited I was. That itself is a motive, and it took 10 years to make a fundamental contribution in that aspect. I want to share here a very true story that happened. It was a Washington DC metro station and it was a January morning in 2007. The man with a violin played 6 back pieces for 45 minutes. During that time, 2,000 people went through the station and most of them they are on their way to work. After 3 minutes, a middle-aged man noticed that there was a musician playing. वो थोड़ा slow चला and stopped for a few seconds and then hurried to meet his schedule. 4 minutes later, the violinist received his first $1. वहां पे किसी ने सोचा ये गाना बजा रहा है यूएस वगैरह में तो $1 दिया कि and then without stopping continued to walk. After 6 minutes, a young man leaned against the wall to listen him and then looked at his watch and started to walk again. After 10 minutes, a 3-year-old boy stopped, but his mother tucked him along hurriedly. And no one knew this, but the violinist was Joshua Bell, one of the greatest musicians in the world. He played one of the most intricate pieces ever written with a violin worth $3.5 million. He was the same Joshua Bell that 2 days before in a theater, okay, he was sold with $100. This is a true story. So Joshua Bell playing incognito, meaning disuse, in the metro station was organized by Washington Post as a social experiment about perception, taste, and people's priority. So, question raised. Do we perceive beauty? Do we stop to appreciate it? Do we recognize talent in an unexpected context? So then when we work in the lab, do we have that perception at that time to recognize what is there? If we do not have a moment to stop and listen to one of the best musicians in the world, playing some of the best, finest music ever written with one of the most beautiful instruments ever made, how many other things do we miss in that? And of course in the lab. So that was the thing that probably I also missed, and it took a decade to have this simple proposition that this itself is a calcium binding pole, and just then I should say how the thought was that now you prove it further. So for that you need data. No thought required. It becomes automatically. Now you are not scientist. You are just a simple technician. Science was only till that part. And I read this quote by a professor who wrote a paper how scientists really think. If you find time, go through this paper, and that published in Perspective in Biology and Medicine in 1989. In my view, science starts with neither theories nor data, but with areas in which these are insufficient. So, now a universal calcium binding fold. So, whenever I found a beta gamma crystalline entry in a genome database, I collected, asked for the gene, synthesized this, and kept on publishing one by one. So if I will take one beta gamma crystalline, do calcium binding, publish one paper in JBC biochemistry, wherever I wish to. And it became so simple for me, the publication in a top journal. It does not mean that I was a great scientist. It means I got some clue that, okay, I can keep doing that. Now, I continued working that I have to further probe this family. So whenever there was an entry in the genome database, collect that. And I kept giving the name. There was a protein in brain, so I gave the name brain and crystalline together, brainylin. There was a protein in vibrio, I gave the name vibrio plus crystalline vibrilin. There was my student worked on one protein from methanosarcina. He wrote in his notebook M. Crystalline, so I gave the name M. Crystalline. I even didn't think of that. Okay? And then basically cloned over 200. Maybe I cloned 500. I just wrote to bring down the name 200. Well, my students, when I used to say clone these two genes, and then after a week I would go and ask him, have you cloned Milky? No. Why? Because the rotor has 16 tubes. So whenever I have at least 15 genes to clone, I will do that. Because to clone 1 or to clone 15 will take equal time. I don't have to clone. So he will clone only at least 10-12 ho, to wo clone karega. So one thesis once I came to know that one of my PhD students cloned 88 genes, that was in his thesis. So it became something like, whatever was there in that database, select one, gave the name, collect one, and see, you will find out of the 10, only 4 will work. It is the success rate is always 20%. So sometimes cloning was unsuccessful because sequence was wrong. Sometimes clones, you couldn't make protein because it didn't overexpress. Sometimes it was forming inclusion bodies, you were unable to purify. Wherever we could purify, we studied for calcium binding, and I got a machine called ITC. Don't have to go the technical one, but whenever calcium bind, there will be a heat change. You measure it by thermometry. So this is what we call calorimetry. So many proteins were found to bind calcium. And then I used to feel whatever protein I take, it anyway is going to bind calcium. मुझो में ताप दे के ऐठ में चलते थे साहब के सडनली देखा देर आर प्रोटीन जो बाइंड नहीं करती टू माई स्टूडेंट साला ठीक से कैल्शियम क्यों नहीं निकाला है यू हैव नॉट मेड द प्रोटीन प्रॉपरली कैल्शियम फ्री एंड देन स्टूडेंट यूज्ड टू टेल you to come you got too paranoid, right? You should sometimes trust the negative data too. So what happened? Okay, some protein did not bind. Why? Let us basically solve that crystal structure. Let us solve whatever was there. So selected as many protein as was possible, crystallize all of them. Okay, and solve the crystal structure. Now was the thing. Number one, I was lucky to select those proteins which were found to bind calcium. And all proteins have the similar way of binding. They will bind only at the same place with the same sequence. But that is what we proposed, that this is a motif of a calcium binding, and this is what I actually now could write whatever I feel. This is how the motif is. Now this is what it does. Now you can keep making the story out of this, and you can fill up the pages in the manuscript. Okay, this sequence should be there. You mutate this, it will not bind, and so on. Some student started giving name that okay, you name it Sarma motif. मैंने कहा नहीं, immortal मत बनाना है. कभी भी मर जाना ठीक होगा, नाम नहीं देना है. So that is why I started sweating when Professor Singh started talking too much about me. तो मुझे लगने लगा यार थोड़ा सा नहीं, it is better to remain a scientist, don't want to be in limelight. We don't want to, actually we feel good in the paper, in the science, and not in the name. So well, coming back to this, so there were the protein which did not bind. We published all that very easily. But we know that, okay, this protein doesn't have the sequence. Okay, this another protein, what we had, it didn't have that canonical sequence where calcium will bind. There are basically the sequence that some amino acids are missing. So all that was there. So we knew all this basically very well. So we also knew why I was so unsuccessful about lens protein that was taking time. Because 3 of the 4 sites were naturally disabled, which will not bind calcium, and I was unable to see crystal structure in the beta crystalline. एक तरह से अच्छा था, because if we could see the calcium bound to the beta crystalline, it could have been published by the London group to solve the crystal structure first. बहुत झगड़ा होता था मेरे और उनमें प्यार से. Okay, we collaborate later on sometime because they used to say it doesn't bind, I used to say it binds. But later on I came to know that why it loses the affinity because of this mutation. Naturally, the calcium binding is disabled in these proteins. So basically we have the motif defined that this is what the calcium binds, and this is where the science was just work, finished and published, and you can actually see, you can publish a series of the papers one by one everywhere, and all beta crystalline and gamma crystalline, and then so, and every piece was a unique one. I will take a protein and will have something else because their function was different. They were not doing the same thing. And now the solution in 20 years, basically that it is a beta gamma crystalline fold, and we can have a entry into this. Everything is always okay in the end. If it is not okay, then it is probably not the end. And finally, I was invited by JVC that you write a mini review, which itself I felt honored about this, and basically made a contribution to that one. And this 25 years journey was something we should not have taken this one. Just for the sake of fun, let me read this quote for that one day Pablo Picasso was a great painter, was sitting in a cafe, and he started sketching something on a tissue paper that was a small napkin paper. Then once he was done, a secret admirer recognized him, approached him and asked whether he could have that napkin. Sure, but you have to pay 20,000 bucks for it. Why 25,000? It took only 5 minutes for you. Arre, no, it took not more than 40 years. So, basically, this was possible because of that the gang I had with me, they had immense trust. Everybody, I made a rule in the lab that they will do the workout with me, then only they will do PhD with me. Okay, and they were all, many became the model, and then that few girls here, they were able to do 1,000 squat without rest. Okay, so you could see how strong they could have been. They were never walking in a corridor. The idea was because they should remain fit and they should be positive with the energy. And my condition was, if you say I myself will do, no, you have to be trained with me. Because I was a professional trainer and I know what to do and how to train, and that was the case. And that is where the life ended. But the journey never ended. Because whenever we have nothing to answer, we always say it is the evolution. The biology people may say, ये क्यों हो रहा है? Evolution हुआ है. Okay? So there were बहुत सारी चीजें हुई. But if you have a few minutes, do you have a few minutes?
Yes, please.
Or am I taking more time?
No. Story is very interesting. It is now more interesting now. What is the future?
So, I'm sorry if you are getting bored, but
No, they are all excited. I can see them. Smile. Let's give a big clap.
no.
They are all engrossed in your presentation. No?
So what happened, how I was trying to see, how the research question came automatically and how it was developed and evolved. There were, so many entry in the database because of the human genomes. And the beta gamma sequence was everywhere. And I was picking one sequence and working. And it was something, because, you will ask a question, why? Because I wanted to know, calcium karta kya hai? Because we are still very far.
Correct.
Answer was not with us. So we kept on working. But I want to tell you, by the time I came to know that, okay, some proteins do not bind calcium because they do not have that particular sequence. Sequence देखते ही we were able to say ये bind नहीं करेगी. But before that, we could clone such sequence. So I thought, hey, let us classify these proteins. So I used to say attractive crystalline, मतलब खूबसूरत है. And then second was boring crystalline. So one of that boring crystalline was actually cloned by one of my students, and then we started working on it. Of course, we were working on a couple of things, that why it is disabled in certain things. So idea was that let us see, the perspective was very different, because every crystalline was very unique and it was giving me something very, very interesting result. So most important among the bacteria is one class called Archaea, which is a separate class, and they are methanogen. And then I found that one methanogen has a calcium binding crystalline, another does not have. And Then what the name we gave? The methylene. And M crystalline, I told you. So M crystalline bind calcium, but methylene does not bind. I used to say it is a boring crystalline. But student did some work. So anyway, M crystalline work was a routine work, so we published this. But methylene work was something, it did not have that canonical sequence. अरे यार तो ये वैसा ही है, तुम एक पेपर लिख दो, स्टूडेंट ने अपने आप एक पेपर लिख दिया, एंड पेपर लिख करके इट वाज सबमिटेड इन 2008 इन टू बायोकेमिस्ट्री, and biochemistry paper it was rejected, and then comment it is the same love letter from the editor. Unfortunately, as you will see, neither reviewer feels that work is appropriate for publication in biochemistry. In view of the nature of criticism, I am afraid we must decline your manuscript. तो कोई बात नहीं, हमने कहा क्या करेंगे. So okay, the paper may be reconsidered for biochemistry if you substantially revised वगैरह वगैरह. We did not do that. In the meanwhile, the what to do? The rejection was not a rejection, and we decided not to do any paperwork till the job is done. तो क्या करोगे? Crystallize the protein. The student just joined the lab. I told him he was going to home on Diwali. घर जाने से पहले ये प्रोटीन क्रिस्टल को लगा के जाना है बस. And he put this protein for crystallization, okay, and solved the crystal structure.
Very good.
क्रिस्टल स्ट्रक्चर सॉल्व की और उसने दिवाली की छुट्टी कैंसिल की. क्यों? Because it was a very, very different crystalline. Three molecules came together, and in the between there was a transition metal. ऐसा बाइंडिंग कहीं नहीं होता है. Three different molecules coming, and histidine, my biology group will know that three histidine, two histidine from one chain, you cannot predict. And
What is that metal?
huh?
What is the metal binding?
It will bind nickel, cobalt, or zinc, any transition metal. But we found in the crystal it was nickel. And क्यों बाइंड करेगा यार ये ट्रांजिशन मेटल. उसकी दिवाली खत्म हो गई, बट दिवाली मनाना शुरू हुआ. द रिसर्च स्टूडेंट वाज वेरी एक्साइटेड. मुझे अभी भी याद है जब वो बहुत से दौड़ के आ रहा था और मैं कॉरिडोर में खड़ा, एंड ही सेड शर्मा जी जल्दी से आइए. मैंने कहा क्या हुआ? इट्स अ वेरी एक्साइटिंग थिंग. अरे भाई हुआ क्या है? मैं जोड़ के चलिए. वी वर एक्साइटिंग बिकॉज beauty excites everyone, even for no obvious reason. Because इतनी खूबसूरत वो स्ट्रक्चर को देखे और उसने बनाया ये कि हार्ट के शेप में निकल कैसे रखा है.
निकल का
ये निकल है बीच में, और वो जो है वो पूरा का पूरा इलेक्ट्रॉन डेंसिटी है क्रिस्टल स्ट्रक्चर की. अब मैं सोच रहा हूँ भाई ये क्या हो रहा है. 2008 से 2017 में ये पेपर छापा, बिकॉज वी send it to PNAS, we send it to a couple of journals. Okay. Finally, we published in biochemistry. Okay. But it lead to something. अब मैं बीटा गामा क्रिस्टलिन के बारे में अपने को दादा समझता था. मैंने कहा तुझे कुछ नहीं आता है बेटे, because the situation was before I was married I had 6 theories about how to bring up children. Now I have 6 children and no theory. I will not talk about this further, but it lead to something कि भाई ये एक प्रोटीन नहीं हो सकती, बहुत होंगी. And we start searching the database, there was no more protein. But after 2017 we started finding many protein because we knew the sequence. दिखते ही लगेगा निकल से बाइंड करेगी. Okay, and then we started cloning. तो क्लोन नहीं होता था तो we used to in vitro synthesize the gene in the lab because how to get that bacteria. मुझे नहीं देते थे वो लोग. Okay, and one example is this, that we took it and then बीच में देखिए वाकायदा ट्रांजिशन मेटल बना हुआ है, and I'm just writing this paper further, okay, yet to be published. eh. So I will say the journey start हुई, खत्म नहीं हुई है, and if I used to say something, कि भाई I know beta gamma crystalline, I'm sorry, I still don't know because other molecule will be very different, and one of my PhD student who was an artist wrote this sing song. True, without it you can't behold. Silence is no longer the soul stronghold. Willingly unfolded or preserving to fold. Thus goes the tale of the beta gamma fold. Thank you very much. And I just say that ninth chaplain, chaplain said that people applaud me because everybody understands me. They applaud you because no one understands. But we understand you. I'm neither chaplain nor auntie, but thank you for your kind attention and thank you for listening to me. And I
Sir, some comments on your this diabetes work.
oh actually that question came when Sifali said that I had to speak something, then I had a question. Kya? So हर आदमी सपने देखता है नोबेल प्राइज का. मैंने सपना नहीं सचमुच में देखा यार, अब तो तेरे को कुछ होने जा रहा है. I just want to say I had a heart attack and ऊपर गया खुदा के पास तो वहां से जगह खाली नहीं थी, वापस भेज दिया. To go to Amity. So I was at home for some time, some days. So my student thought ये तो गया काम से, तो कुछ करता हूँ. So I don't want to take the credit. I want to give the credit to the student. Okay. I want to tell you, I was lucky to have the best student from the batch. So there were few things. आप अपना नाम बढ़ा दो, तो best people will come to you. So somehow CCMB became a core name. So that top student will get selected 5 places. Okay, but will join CCMB. I don't want to take other names, but somebody said that यार अच्छे लोग तुम्हारे पास चले जाते हैं, we get the second level student. Or we used to select 5-6 students. The best of the 5-6 used to join my lab. I don't know why. कभी कभी होता है ना कि मेरी शकल पसंद आ गई तो ठीक है. अब those students basically थोड़े से ही दिन में they used to become someone because कुछ होता था उनमें, उन बच्चों में. मेरा जॉब था उनको ग्रो करना. So he came and he said, I have some other problems in my mind. I mean, what is that? There is a protein which is secreted in pancreatic beta cell. Pancreatic beta cell is where insulin is secreted. मैंने कहा इस पे क्यों काम कर रहे हो? He said that Simit ही आया था अभी कुछ दिन पहले. He was a Nobel laureate. The guy who got Nobel Prize after his work was done after he was 60. And he showed a slide there, and the slide में था, I had also attended this talk. तो उसमें लिखा था, if you want to be famous, you work on insulin. And that slide was of 1956 की थी, मतलब उस टाइम का कोई कोट था. Okay, and my student said, this protein is secreted in pancreatic beta cell, and there is something with diabetes. I want to see whether it bind insulin. मैं भाई करो. उसने दुकान पे गया, परचेज इंसुलिन, came and did the calorimetry and he sent me the data कि ये बाइंड कर रही है. मैंने कहा पेपर भेज दो. उसने कहा नहीं, I need to find out what is the significance. अरे यार भेज दो ना. मैं कि no. Now comes one day and tell me, I want to inject secretagogue in a diabetic mouse and then see whether it affect. मैं दिमाग से निकाल दिया यार अब में जाना है and so many things we will do it after a while. But दिमाग में था. We both went to a conference in US. तो कैल्शियम वाले लोग मुझे बुला लेते थे किराए पे. So हाँ भाई चलो चलते हैं अपने दोस्तों से मिलाते हैं कैल्शियम से. I was keen to bring one calcium conference to India. मैंने कहा एक बार यहाँ करते हैं. In fact, you know, I was quite successful, but the guy came and told me in private, बहुत तंग करते हैं, वीसा नहीं मिलता. Who will like to come to India? We are not. And then conference went to Japan. I told them I will go to the home ministry and there will be no issue. यार तुम कर दो. So by the time that it was bid by. So उस conference में he was showing it the poster and then one guy who was a discoverer of EFN, he asked, tell me one experiment that you will do. He said, I will inject secretagogue. मैं बोला साला मेरे को 6 महीने से बोल रहा है तू काम नहीं करता है. I came, called the animal house guy and I told him, यार no ethics. चुप से 4-5 चूहे दे दो. In the between we will write the grant that proposal. And because CCMB is one very good institution where you can do whatever experiments you want. I was lucky, and that's how this work could be done. All that. So, and then I told that person, you book my ticket to Sweden. I am going to take the Nobel Prize next year because now it is diabetes, and if you cure it, nothing like that. Big society, social problem will be solved. We all are going to have the sugars by the time we reach 40, 50, 60 or whatever. So, he injected, we worked on it, we submitted the paper to the Nature Medicine. The editor met personally and said that he cannot accept the paper. Orally he said, and he said that he will publish this if you take the knockout mouse and you inject in this and then I will take it. By the time I became basically old and I was leaving CCMB, और बुढ़ापे में I can't be like Professor that चौहान साहब की तरह तो हो नहीं सकता हूँ. Okay, but कर नहीं पाए. आज भी actually when I was leaving CCMB, I thought I am not going to join ICER, I am going to start up because the moment you add secretagogue in insulin, the insulin efficacy is increased. Why? What is type 2 diabetes? Type 2 diabetes is that your body is resistant to insulin. The moment you add secretagogue, your insulin resistance is reduced and your body will start becoming towards normal. Of course, with over the period of time, of course, you have to control a couple of other things. But if you have the cure in this form, that your protein being given to you, that means you are actually attacking the basic problem because beta cell regeneration start and secretagogue act as a growth factor. So if you add secretagogue in cell, you see the more cell division. Okay, but not alone. Only with when it is with insulin. So you add insulin is a growth factor. You all know basically because it acts on the cell. But when you add secretagogue in it, the potentiality is very high. And so it has that kinds of a future, that what we call the future medicine. And then probably if there is a chance and if there is something which I could do, I would try doing this again. I lost, yes sir.
But I thought because a lot of media attention was drawn.
Yes.
Why it could not take up? Because this secretagogue is a cytoplasmic protein.
No, it is
a cytoplasmic protein. So suppose you inject that, how it will be internalized into the site of.
Yes, actually we did this work. This is a very good question because there is a endocytosis and exocytosis happens. It enters into that cell. We worked for this to find out the receptor of secretagoguin, and then by the time कोरोना आ गया और मेरा स्टूडेंट चला गया, नहीं तो मैं तो सेल के लिए पेपर बना रहा था बाकायदा. If I could identify that receptor of the secretagoguin, so there is something which allows it to go to the cell inside. We could see really that it is entering to the cell. If it doesn't enter into the cell, it will of no use to us. It even crosses the brain barrier. The न्यूरोडिजेनरेटिव डिजीज होना ही होना है ना. बुढ़े हो गए तो हाथ कांपेगा. यू विल हैव पार्किंसन. व्हाई? बिकॉज सेक्रेटागोगिन लेवल इज लो. इंजेक्ट कर दोगे तुमको तो थोड़ा सा ठीक होने लगोगे. It stopped fibrinogenesis of synuclein and other those proteins which are there in the brain and which actually stops, which creates the problem for Alzheimer's and so on. So lot many things could be done. I was in a lecture in Europe. So that lady who sits in the Nobel Prize committee, uska sentence tha, this is a protein of the next decade. मैं बोला तो मैं अच्छी प्रोटीन पे काम कर रहा हूँ लग रहा. वेरी गुड. अपनी मूंछों पे ताप दिया यार कभी कभी. हम भी दिखा. Anyway, thank you once again to all of you. And Johan साहब.
बहुत बढ़िया. Dr. Murthy, who asked this question about insulin, which of my faculty touched this topic of insulin? क्या नाम है इस faculty का? अभी किसने पूछा?
AK Singh.
AK Singh, right? Okay. Because this has a lot of scope for further research. So AK Singh will meet further, Sharmaji, and will further deepen your thought. Wonderful thought. Pooja, Nidhi was asking a little background of research background of Yogen Sharma ji. उसको बोलना इनका बायोडाटा पढ़ लेगी. It is like a thriller. It is like a thriller. I tell you, I started reading today at 3 a.m. and finished at 5 p.m. and then I could not sleep because there is so much for my scientists, so many memberships, so many awards, so many things which my scientists should know. Sir, my scientists are brilliant, but they should know where to get award, who is funding. So in your biodata, everything is there. Dr. Murthy, you were 3 times in CCMB. Yes. You were from DRDO to CSIR lab. What was this?
We did a very interesting experiment, which is our psychoneuroimmunology.
Okay.
In breast cancer patients, and when you measure their stress profile, perceived stress, because for a lady, mastectomy being done, then radiotherapy, chemotherapy, it's a very highly stressful for the women patients.
Right.
So how does that affect the neurohumoral axis, which will be sympathetic pathways and sympathoadrenal pathways, that is cortisol, catecholamines, then ultimately affecting the immune system, which is CD4, CD8, NK cell, PHA, all those immune system. So we were looking at what is the coping strategy of the patient, because some people want the problem, oh, it's my fate, so I have got this. Some people will avoid. So there are various coping strategies. So we correlated by a multivariate analysis which are the coping strategy helps in the prognosis, which helps to limit the progression of the disease. So we were doing that study where CCMB was involved in these cellular studies, that all the immunological profiles, CD4, CD8, NK cell, all that was done there. And Bangalore Cancer Research Foundation get the patient's profile. So we had Kilara, Brinda Sitaram there. Then DRDO, DPAS and DIPR were measuring the perceived stress using anxiety level, state anxiety, tilt anxiety, what is the perceived level. Then we also measured cortisol, catecholamines in the DPAS. Then the CCMB was the partner. So even Dr. Kalam and myself went together for a review. After the project was sanctioned, Dr. Abdul Kalam and myself went for the final review when the report was submitted. So like that, I have visited 2-3 times at that time. They have a beautiful animal house. They have excellent facilities for molecular and immunological studies. So that is the visit to CCMP.
I was also associated with the CCMB when I was in Hyderabad University.
Very good.
So my one question is that in the diabetic patient, there are a lot of unfolded protein response happens in the pancreatic beta cell, and they're connecting it to the diabetic retinopathy, for example. So your crystal in the secreted protein that you had talked about, does it meet with the mechanisms pathway? Because unfolded protein response,
It does actually.
it activate this protein and enable to bind to the calcium protein. So by targeting mechanisms, you can release the unfolded protein response so that it really binds to the target and does its business.
Yes, this you are very right. It is a correct point. We have done this work and we have shown that it is involved in that unfolded response. No, it does, and then it
He
is.
is Dr. Hirdesh Prakash. He is working in Amity Center for Translation.
Translation Research Valley.
And Sphingolipids is this. Please.
Yeah, we have done this work. We have done, and then it is involved in that. That is why I said that synuclein is also that protein, unstructured.
Because whenever mechanism gradient is high, it will prevent the binding of this calcium domain to the calmodulin. It inactivate calmodulin. And considering the immune toxicity of the calcium protein, this is very important aspect for releasing the T. The T cell and the MDSCs need to work together in concert to maintain the insulin sensitivity.
Yes, you are like that.
So anybody else now, younger faculties? How do you want, you first on the topic?
It's nice. You have many questions and I will come again and talk to you all. I mean, I haven't.
Yeah, he or she wants to ask. Just pass on the mic. Shefali?
So,
Please tell your name, please. When you ask question, please tell your name.
yes.
Introduce yourself.
Manoj Garg, is it Manoj Garg?
Yes, sir.
Okay, I recognize you.
Thank you, sir.
Please ask.
Hello, sir. Good afternoon. It was really a very interesting and very fascinating talk. A lot of knowledge I've gained. I work in the field of neurodegenerative diseases, and as you mentioned in the last part of your talk, I also wanted to know that I have heard for this secretagogue protein for the first time. I have been doing insulin. I have been studying about insulin regulation and its effect, and its leads to your Alzheimer. So this secretagogue is also a fish of protein.
It is actually a stress protein. Stress protein. It does not belong to the heat shock. But we may find some heat shock element in it, but that is just a prediction, not so close. But if you see the expression of this protein by heat, yes, we see the elevated expression of secretagogue.
Okay. So it will also lead to amyloidogenesis then?
Focus.
It will also lead to amyloidogenesis?
It is, yes. In a what you mean, neurodegeneration?
Yes.
Yes, it is. That is what I am talking about. I told that basically alpha synuclein, it does bind and protect from fibrillogenesis.
Yes.
Okay. And we could see one paper in PNAS later. I found that in post-mortem tissues from some limited number of human sample, the secretagogue level was found drastically low in those. So there is a correlation. But these are multifactorial disease. We can't go on one factor. 100 things ho sakti hain. In some cases, this may be parameter, but it does not mean that you have a proper secretagogue level, but still neurodegeneration. There may be other problems too. Multifactorial disease. This is one of them. Quite complicated. These are all complicated diseases,
Yes.
But at least if we know one thing, we will know another thing. We can keep connecting together
Yeah. Because insulin is very prone to amyloidogenesis. Causing
Yes, it protects that. It protects insulin amyloidogenesis. It protects A beta 42.
A beta 42.
We have not published A beta 42, but we published in that synuclein already. Yes. And we are now doing NMR
Okay.
with that.
Please tell your name. Who asked this question, please?
Sir, this is Dr. Shruti Ahuja from AIB.
Okay. So I am not. I don't understand from your voice. Shruti Ahuja. Okay.
Yes.
But very good question. I think we should follow. It's wonderful. Good.
Thank you.
So she has joined very recently. And
Okay.
when did you join? Just
I joined in July.
Okay.
This year.
And where are you? Just tell sir, where
your
are you?
background.
Oh, background.
So basically, I'm a chemist like Dr. Sharma, and I did my bachelor's in chemistry honors and master's with specialization in organic chemistry from Delhi University, Hansraj College. Followed by that, I did my PhD with from IT Kanpur with Professor Sandeep Verma in the field of bioorganic chemistry. And later, I worked as an NPDF fellow and an institute postdoc fellow at IT Delhi. And I worked in the field of biomaterials
Right.
and with applications in anti-cancer, neurodegenerative, and and antimicrobial. Yes.
Great. Wonderful. I'll meet you sometime, Dr. Mamurthy. We'll meet you.
Yes, sir.
Thank you.
I want to have personal contact with all my brilliant scientists from all my universities. Dr. Mamurthy, next year when our MIT University Hyderabad starts,
Yes, sir.
take a 15 member delegation to CCMB.
Right.
We will talk to Kalai Selviji that founder was so happy to read about CCMB for the leadership. So the 15 faculty members select from our campus, maybe few from Manesar, and I will try to personally come because the CCMB one has to learn a lot. So
Yes,
we'll go as a delegation in next year when the MIT University will be starting in Hyderabad also.
So, why CCMB? You will make the better CCMB in MIT.
Sir, ऐसा है. In between, I went for a few minutes to other meeting. We were having a negotiation with a foreign university, very renowned. They want to make with me a joint university in this in Ahmedabad in the gift city. And we were quite advanced in the negotiation. And then my people told, sir, now we are advancing in the final stage of negotiation. Can you please attend? So I was so enthusiastic that I want to make 3-4 universities within a foreseeable time in Gift City because the rules and regulations are very relaxed there. And Abhi Asimji was there a few weeks back and he had held it round of that. Before that, Atulji was there to Gift City. And so we are very much following because as technology told, collaboration, cooperation, connect, and synergy of brains. These are my Brahmastra. Dr. Murthy,
These are the Brahmastra.
these are my Brahmastra and outcome. Today, my faculty may be a little worried. 100% outcome, I will tell you. I know. Set a mission. This is done and nobody can stop you. Sir, Sharmaji, you were telling about this brain degenerative disease and all. You are only 65, 66.
Yes.
And I have written your name in 2047. I will dance and sing with you together. You will be 90 years old and I will be 105 years old. So don't worry.
It will happen. What the founder president dreams or desires happens. So it will happen. You will also be there.
Any other faculties, Shefali, if you have to skip some visit of the institution today, Sharmaji will come next time. At the moment, it's important that my faculty member just have some interaction, ask question, so that they know later on they can also follow with him. So if we can skip today and so on. And therefore, let any few questions, please feel free to ask.
Manoj wanted to ask something.
Good afternoon, sir. I have done my PhD from NII, then postdoc from University of California and National University of Singapore. I worked with Professor Abdel Surulia, who transferred the 20,000 US dollar technology for insulin release at that time point when he was the director of
NII.
NII
So I have very specific question. When you find this calcium binding protein, specifically in terms of cataract, did you try to make a knockout mice and see whether it is causing the defect in the lens formation or in the vision or it has some other role? So that is one thing. Second thing, when you talk about this scretogogue, which channelize the pancreatic cell. So, apart from this diabetes, pancreatitis is the major problem which start before the diabetes. And when it lead to the chronic, it lead to the lethality. It also lead to the pancreatic cancer, which is one of my field. And our Honorable Defense Minister Manoj Parrikar earlier died because of pancreatic cancer, because there is no disease so far in the world. So the problem happened with the pancreas. So my thinking and my think that we can work together. Can we look, induce the chronic pancreatitis in these in mice, and we'll look whether secretagogue make them better, and maybe that's the reason we can look in a broader aspect than the diabetes.
वेरी गुड पॉइंट. एक्चुअली उतना दूर तक जाने का ही जरूरत नहीं है. पहले से ही देख लो that you know that cholesterol, high cholesterol and secretagogue is the relationship. So we still do not have the data, correct data that secretagogue level and diabetes. In fact, I started working that whenever there is a COVID, okay, what happens to the secretagogue level in the blood? So being protein in a blood, it has several roles, many places. And that is why one can look into the functional aspects like what you said. Yes, very much, and it may have a role somewhere else, surely. Okay? We can try to do that work.
Yeah, we can try to do that.
Yes. How do you underestimate?
Just introduce yourself.
From
Yes,
cells.
Antibody.
Antibody.
Just antibody, just ELISA कर लेते हैं. ELISA होता है वो antibody है.
This procedure, collateral.
So Manoj, can you just give some thought, crystallize a concept note, make a concept note, and then you discuss with Dr. Das also, and then we will take his advice and see how do we make a strong proposal. And we must also, if the concept is new, then we can even file a notional provisional patent. And then
We can request Dr. Shruti also to be a part of
that
it.
Shruti, you can be a part of this.
Because you also work in a similar area.
Yes.
Since you also work in a similar area,
Sure.
so probably you can meet Dr. Manoj,
Sure, ma'am.
right? And you can be a part of this team. And we can identify more faculty members from AIB who have similar interest, and we can maybe have a meeting together.
Very good. So we have crystallized one proposal. Now let's.
Hello, sir. I am Dr. Shinjini, and I work on amyloid proteins. So,
बहुत नजदीक हो हमारे.
yes, and therefore your talk was really amazing, and I really learned a lot, especially your journey. So I'm a Wellcome Trust Fellow as well, and assistant professor here. Prior to this, I worked at IIT Bombay for 8-9 years, and then my PhD is from Indian Institute of Chemical Biology. So so what I do in amyloids is that I work on P53 amyloid, and our group was the first to show that P53, when forms amyloid, has a gain of function, and those gain of function are tumorigenic, and it leads to cancer progression as well. So when I heard about this protein secretagogue and that it can inhibit fibril formation, so is the binding based on a random structure? Is it a random structure or a random head, or is it the structure based binding? Because P53 is not entirely random. Different domains are there, and if some domains are completely alpha helical, and some are, some are random. Probably the N-terminal is random. So is this binding possible, or can we use this for the sake of cancer and for the sake of temerogenic to reduce the properties? That was my question.
Very good.
A very good, thoughtful question. Now, we still do not know whether secretagoguin will bind with P53, but it is worth trying, and it will be a novel thing. That is first thing. Second thing is, protein don't have to be unstructured for binding secretagoguin. ये आप लोग हिमांशु का नाम सुन रहे हैं ना, फाउंडर साहब ने भी कुछ बोला, तो he is doing NMR there in ICER currently, where we are checking binding होती कैसे है actually with secretagoguin, but इतनी बदतमीज प्रोटीन है, ठीक है, हाँ, नहीं, basically that an expert like Himanshu, he said, yes, it is such a challenging one. We are unable to get a very good HSQC, that spectrum, that an NMR. So unless we have that perfect one, we cannot assign. Right? So we are facing issues for doing the structural one. We couldn't crystallize it properly, okay? Because it is quite dynamical protein. So a protein which happen to bind several ligands, it will not have to be a very robust one. It has to be flexible. Then only it will bind. And flexible protein mean it will be quite dynamic. It means you can't solve these structures. The structure will not be important in that case. But it is worth trying, and you should do that. I have the clone and I will give you the method. Very good.
So this is the second area. Somebody is looking at.
Hello, sir. I have a question there. My name is Biren Kumar and I am from IMSA. Dr. Das. So I have a question for your last part, that when you saw the three proteins, three monomers, and you model the nickel in the center, and when you saw the density like it's a triangle.
Just keep it closer.
Kind of heart shape. So my question is, because you started with the calcium, how you decided that it is not calcium but nickel? And then why there are like only one molecule? Because for me, I'm also a crystallographer. I work with the commodines, and I tell you, one time we had difficulty when we were, solving the commodine structures. The reviewers were, arguing that it's not, calcium, but it may be zinc also, because we have zinc chloride in the crystallization condition. So, and here also it looks like a triangle shaped density. So if I can argue, why not three molecules, why you just put one molecule there? Yeah, thank you.
So a few things. Number one is that electron density map for each element is different, and you can easily check whether it belongs to the calcium or someone else. Number one. Second thing is calcium binding is very subtle. For calcium binding, you cannot have a binding where you have, say, negatively charged amino acid doesn't mean it will bind calcium. Calcium is designed as a signaling molecule. Nothing can happen in the body without the hierarchy of calcium is topmost level. Okay? It means the calcium binding cannot have a fixed structure. Whereas that this binding of a transition metal is based on the sequence. You put up 6 histidine, it will bind anyway with the transition metal. Okay? So there is no question about checking whether it is transition metal or it is basically calcium. But yes, we have had this issue whether it is nickel or whether it is cobalt. Okay? Both were quite similar and we checked that. So because sometimes depending how the crystallization conditions are, so it was also cobalt in some cases, it was nickel in some other cases. Okay. And because it will bind any other thing. But when it's calcium bind, it will bind only calcium. कुछ और bind नहीं करेगा वहाँ पे. Because that is the binding to a pocket and not amino acid sequence. Okay?
Good, very good question. Anybody have
Yes,
please?
Hello, sir. I'm Dr. Yogita Adlakha, and I also joined AIMSR Department of Amity University last year. And I work on brain development and neurodevelopmental disorder, basically. And before coming here, I was research scientist at Translational Health Science and Technology Institute, Faridabad. And I also worked with Dr. Anand Swaroop at NIH, USA. And I worked on retinal degenerative diseases such as Leber congenital amaurosis.
So my question was that you told that this protein is also plays some part in Alzheimer disease. So I was wondering whether this protein forms some kind of interaction with the mutated proteins such as presilin 1, presilin 2, or amyloid protein.
See, how much we know about this is some published result and some unpublished from my lab. It binds very specifically to any protein which form fibrils. So we checked with model protein. Okay. So, or you take a protein which forms a precipitate. Simple experiment. This protein form a precipitate, you add secretagoguanine, it will prevent the precipitation. Okay. This is what the simple test, laboratory test of checking whether it is a chaperone. So when we call chaperone, it is a general chaperone and not a specific one. And that is why it may have a role. And we feel it has because it also expresses in the brain. Okay? I do not know what the cognitive function it may be related with. Okay? That need to be checked later. But as of now, it has a physiological significance in our neurodegeneration. This much we know.
So as you are telling that this is expressed in brain, so do you have antibody for this particular protein?
ये basically हाँ protein antibody तो बाजार में भी मिलती है, खुद भी बना सकते हैं. We made in the mouse and that time we used to basically do that.
So because we checked some of the neural stem cell marker, how they go orally during the disease and during development, how they express. So we can also check your protein in our stem cells also.
Yes, it is possible. It is possible. We did work on couple of things actually. देखो बहुत सारे interesting features होते हैं. One is जहाँ जहाँ इंसुलिन होता है बॉडी में वहाँ secretagoguin होती है. Yes. ये हमने देखा अपने उसमें एनालिसिस में. But these are not the facts which are there in publication or something. So we were curious to know its ABCD of this one. That's why. It is much more. I wish basically अभी मुझे लग रहा है शायद उसी पे बोलना चाहिए था मुझे. हाँ. तो मैंने सोचा कुछ चीजें नहीं बताते हैं. शायद एक रीजन ये भी था कि if I speak on secretagoguin, everybody will ask questions.
See, people are asking no big questions. It shows the depth of understanding, the grasp of the subject, and your own contribution. Let's clap for all those who ask questions.
अब वाली स्लाइड है ना वो सही थी.
I am Dr. Mandal from Biotechnology. I have a quick question about crystalline molecule. So, is there any natural variant of the crystalline molecule or protein?
वो माइक बदल दो ना. अच्छा काम कर.
So, my question is there any natural variant or mutations found in the crystalline molecule that can lead to eye disease? I mean, it's an important protein for lens formation, right? So, is there any information about the mutant proteins that lead to blindness or any genetic diseases?
देखो भाई there is a question called practical thing. So your question is very good. So we had a very close collaboration with LV Prasad Eye Institute, okay, about this cataract crystalline mutations. We used to screen all that. Now that LV Prasad, the founder director GN Rao used to come and tell me, why are you working on cataract? We can easily remove this lens and put another one. कुछ और करो. Okay. So basically that was something very, very practical point. Okay. But yes, there are mutations in certain gene and then we know this in juvenile cataract. Okay. So pediatric case आते थे and then we know that mutation in beta crystalline, mutation in alpha crystalline and so on. And like somebody asked this question that, okay, why don't you actually make a gene knockout and what happens to this? He asked the question. So all those things are known very well that, okay, what is the function of beta crystalline? So you that is called the functional study. You make a gene knockout and see what happens. So all those things are pretty much known. And we know now that crystallines are not specifically to the lens protein. Beta-casein also expresses in the brain, and somebody connected probably that they play a role there also with respect to calcium or maybe something else. Our science is not yet that good that we can just simply say this is the function of a protein. अभी शुरू ही हो रही है हम लोगों की मेरी basically science को. More advancement comes whenever more instrumentation comes, more methods come. Now gene jockeying से हम जो है gene editing को चले जा रहे हैं. Okay, biology is something every 10 years it changes. So with more and more advances, and what is there is that we also need to keep pace with the new discoveries.
Absolutely. Thank you so much. Let's give it to Deepshika. She wants to make some comments. Deepshika Pandey. How many years you are in Amity?
मेरा introduction तो हो गया
We were yesterday discussing a lot, and I'm here for the last 16 years. And we had yesterday when I was talking about type 3 diabetes. So interestingly, just I was looking, as I told you that the insulin degrading enzyme, we made it a hero because it is already into cognition. So in that pathway, the secreta globulin was also there, which we did not look. So today when you are giving this insight, so let's see, because you are saying that maybe it has some role in cognition. ID definitely has a role in cognition, so maybe we can really look further for this particular theme.
Yes, of course.
So yesterday we had a detailed discussion.
Dr. Murthy,
Yes, sir.
Shefali,
Haji, sir.
now you have to go for lunch because 3 o'clock you are going to meet VC. Because
आपकी फैकल्टी ऐसी है खाना खाने ही नहीं देती. They are involved in science so much.
Shefali, there are no technical scientific topic, just have a relaxed time for lunch. He will be coming quite often to us. We can have all these questions, all these follow-up later. अभी चल जाओ lunch पे, and whoever wants to go, ring to Sanjay. So many people are coming. Have a relaxed to refresh the mind. Go to lunch, and then 3 o'clock sharp. Just 2-3 persons should go to Vice Chancellor. More are not needed, so that Vice Chancellor has one-to-one interaction with Yogen Sharma ji. I have just sent the detailed biodata to Dr. Brinda Shukla so that she has information about her distinguished career before he reaches there. Sir, the Vice Chancellor is since for 24 years with me.
Very nice.
You were more than 30 years in CCMB, and because whenever somebody comes to me, then cannot go anywhere else because the atmosphere, like family-like atmosphere, people like A.K. Singh, Neeraj Sharma, Shukla, Dr. Silva Murthy, and all these people are like a family. Where do you find this atmosphere? Nowhere. So
I could sense right in the beginning, that yesterday when I met Singh साहब, मुझे लगा ही नहीं मैं इनसे पहली बार मिल रहा हूँ. पता नहीं मैं बोला कब से मिल रहा हूँ इनसे और नीरज जी से.
Sir, with your permission, then can we conclude, sir?
yeah, they just Shefali, they skip AIVI and AIMT visit today.
Yes.
But AIN and Dr. Malik's, that is important. So after lunch and after meeting Vice Chancellor, have a half an hour visit in MIT's neuroscience and neuropsychology, and no more visit then. Incubator just for a few minutes, if not visited, library for a few minutes, and then you do whatever you think proper. Is it clear? Clear? Okay.
Yes, sir.
So, okay, good. Thank you, sir. Thank you. Good
Thank you.
Let us give a big clap to Yogendra Sharma ji for his it's a very complicated topic of protein chemistry, protein coding, but he made it in such a simple and reaching out to every mind, heart, and soul of all of you. That shows the ability to deliver as well, not only to do research, but how do you make it interesting to deliver? That's also an art. So Sharma ji, it was great listening to you, wonderful. Only one thing, you have ability to go for a Nobel Prize. No, what I'm telling, nothing, because you have gone deep into one beta gamma. This is not as required. And if we can show, what I suggest is, if we do the data analytics of all that work that you have done, using the AI platform, Puniti Mathur, and also our AI center, should now look into all that wonderful data he has collected over 3 decades. And how do you put it into translating into a knowledge which you could even give a new therapeutic application or a diagnostic? So I would request you to really consider this in a better. We have a very strong AI center. Maybe he can, on the way, he can see it if there is time available. And so this is really, you start thinking in that direction. AI application, data analytics, to go deep into and give a new interpretation.
सर मैं बच रहा था कि आई विल नॉट टॉक अबाउट सिंह साहब कल्पित थे. इन्होंने कहा भाई तुम वो भी बोल दो, मुझे पता था वो हॉट केक है और हर आदमी बात करेगा. बट ही न्यू व्हाट इज सोल्ड इन द मार्केट. तो पकड़ लिया, मैं क्या करूं. थैंक इनको करिए, मेरे को नहीं.
So let's clap for founder.
For Yogesh Sharma ji, not for me. We are all because of him. Good, okay.
Yes, we have a felicitation. Founder president just one. Appreciation. Shefali. You can put the shot. Yeah, up there.
Once again, sir.
Thank you. So all the best. Please follow each up with him later and keep in touch with Astia and they will enable. Shefali could be.
बहुत जल्दी मैं अपनी स्लाइडें बदल रहा था. My presentation was not that good, but thank you for listening to me and my stupid presentation. Have a wonderful day, and it was nice to interact with all of you. Thank you very much.
Thank you. It was a great presentation, sir.
Yes, please go lunch. Shefali lunch को लेके जाओ. No, he is not coming.